In number 22, you have the function y equals square root of x, y equals 2, and x equals 0 as boundaries. Y equals square root of x. Y equals 2 is a horizontal line that will eventually intersect with square root of x. And x equals 0 is the y-axis. So here's the region. And you're working with that in each part. In part A, it says to revolve about the x-axis. Disc, washer, or shell? Washer. So we need pi times the outer radius squared minus the inner radius squared. Actually, how did you determine it was washer? Which way are you drawing your favorite rectangle? Okay, so what's your favorite? If it's vertical, then it's washer. If it's horizontal, it's not washer. What is it? Shell. So you can do it either way, but make your decision before you pick your method. I was getting ahead of myself. So what is the outer radius? 2 minus 0. And what's the inner radius? Square root of x minus 0. So what are the limits of integration? y2. 0 I agree with. What is the x-coordinate where those two meet? Right, we have to set square root of x equal to 2 to find out what x is at that point of intersection, because we're using vertical rectangles, which means we're going across. So when you simplify this, it just becomes the antiderivative of 4 minus square root of x. And that
Why is it square root of x?
this shouldn't be square root of x. When you square square root of x, that should just be x. Okay. So now are we good? So then you have 4x minus x squared over 2 from 0 to 4. And when you put in 4, you have 16 minus 16 over 2. And when you put in 0, you get 0. So the answer should be 8 pi. For this problem, once I get my graph and find my region, I pick the rectangle I would prefer to work with no matter what I have to do with that region. And the reason I prefer a vertical rectangle is, for one thing, the height of that rectangle is always the line minus the curve. I'm always subtracting the same two things to get the height. Secondly, since it's vertical, that means my integrand would be in terms of x. My equation is given in terms of x, so I don't have to do more work to fix that. So it just makes sense to me for this problem to work with a vertical rectangle. You don't have to. You could just as easily, well, not as easily, but you could work with a horizontal rectangle, because wherever you draw it, it's the curve minus the y-axis. But you would have to solve your equation for x so that you can work with y. To me, that's an extra step I can avoid, so I'm not going to do it. But the nice thing about knowing the disk and the shell method is it gives you the freedom to work with the rectangle you prefer. In part B, you're taking this same region and now you're revolving it about the line y equals 2. I want to revolve about that line. Well, my favorite little rectangle is perpendicular to it. So again, this would fall into the disk washer category. And since there's no space between the region and the axis of rotation, it makes it a disk problem. And let me just erase this so I can work right here. So to revolve around y equals 2, it is a disk problem. The radius of my disk is the height of that rectangle. If you can imagine revolving this rectangle around that line, it's going to create a circle. The radius of that circular disk is the height of the rectangle. So I want pi radius squared, and the radius is 2 minus square root of x. I'm still going from 0 to 4. So that's how you set up part B. And it makes more like a golf tee, I would think, than a cone. It's because a cone, the sides are what you call lateral, I think. These are curved, but it is somewhat conical. Okay. So what would you do next? You have to foil it. And what would you get when you foil it?
Wait, Miss Callie, why is it 2 minus the square root of x?
The radius of that, the length of that line right there.
But why wouldn't it be the square root of x minus 2?
If I have a point here and a point here, and I want to get the distance between them, let's say this one was at 6 and this one was at 1. What's the distance between them? And you didn't say 1 minus 6.
So you go from the farthest one to the shortest one.
Top minus bottom, because top's always bigger than the bottom. Right.
Like with disc and everything? And washer and shell and everything?
I hate to say always. Always in this instance, if you're trying to find the distance between two things, distance is a positive measure. So if I want the distance between these 2 points, I would subtract the smaller one from the larger one, top minus bottom. If I want the distance between these 2 points, I would subtract the smaller one from the larger one, right minus left. So what did you say you got when you foiled?
4 minus square root of x plus x.
And then antiderivative? Perfect. And I got 8 pi over 3. Did anyone else? Yay. In part C, it says to revolve this region about the y-axis. I still love my beautiful little vertical rectangle, but now its orientation to the line I'm revolving about is parallel, so it's shells. If I wanted to do discs, I'd have to use a horizontal rectangle. Just requires more work. So the shell method, you have 2 pi, and then you want the distance from a typical rectangle to the line you're revolving about. How far is it between those? Well, since I can draw the rectangle anywhere I want to, and I went over x to get to it, it's x minus 0. The height of my typical rectangle is top minus bottom. And I'm still going from 0 to 4.
Wait, why is it X minus 0?
The distance from a typical rectangle to the line I'm revolving about.
But how is that X?
Because I don't know where I drew it. I went over some amount and I drew it. I don't know where I drew it. I could have drawn it anywhere in that region. I went over X to get to where I drew it.
Is it always X?
No. It is not always X. It is the distance from the rectangle to the line you're revolving about. If I was revolving about this line over here, which we may do, in part D, we revolve it around the line x equals -1. Now it is x minus -1. Right minus left. X minus 0. Because that's what I'm revolving
But
around.
it's always X minus something. Or X.
No. It's always right minus left.
But why wouldn't it be the square root of X minus 0?
Because my typical rectangle, I went over a certain amount to get to it and I drew a vertical rectangle. I didn't draw, I'm drawing a rectangle in that region. So if you prefer to not work with a shell method and you're doing part C and you need to revolve this region around the y-axis, your typical rectangle, you're forced to draw it so that it is perpendicular to what you're revolving around. You don't have the freedom to work with your favorite rectangle. It has to be perpendicular to what you're revolving around. Okay? So since that makes it horizontal, it's all about y. The equation was y equals square root of x, then you had y equals 2 and x equals 0 were the boundaries that we were given. This region is bound by the axis of rotation. There's no space between it. That makes it a disk problem. So for a disk problem, I want pi times radius squared. The radius of this disk in terms of y is y squared minus 0. Right minus left. I'm going from 0 to this line,
Just 2.
which is the line y equals 2. So I can do y to the 4th dy, which is y to the 5th over 5, which is 32 pi over 5.
That's not what you got to the last one.
Yes, it is. It is.
Okay.
We never worked it out, but I asked everyone who had that, did they get 32 pi over 5, and they said yes. Now, and you say, oh, well, that's easier. There are problems when it will be easier or as easy. There will be problems if you choose the other method, you can't do it because you don't know the integration techniques yet to do it, and you're not going to learn them in this course. So that's why I teach you both methods. But, you know, if you want to just stick with one method, the problem is some problems are going to be much harder than they would have been had you known both methods. Yes, ma'am.
Okay, I have a question about arithmetic. Okay, so if you have when there's a number plugged into
In part D, you're to revolve around the line x equals -1. So that's a vertical line. And my preference is to work with a vertical rectangle. So since my rectangle is parallel to the axis of rotation, it's a shell problem. If I drew a horizontal rectangle, what method am I using? Washers. You can do it. To me, it's more work, but yes, it works. So for shells, you have 2 pi, and then you have the average radius of a cylindrical shell, which is the distance from a typical rectangle to the line you're revolving about. Right minus left. What would that be? X minus -1 or x plus 1. And then you need the height of a typical rectangle. What would that be? And then those same old limits, 0 to 4, because we're going across, you have to FOIL that out and then find the antiderivative. Does anyone need to see? The answer is, that I got, is 176 pi over 15. Did anyone else get that? No? Okay, let's work it out then. Okay, wait.
So
when I FOIL this out, I have 2x minus x to the 3/2 plus 2 minus x to the 1/2. So then, integrating, I get x squared. X goes up to the 5/2, so it's times 2/5, plus 2x. X is to the 3/2, so times 2/3. Are we good so far? Okay, so then I put in 4. 4 squared minus 2/5 times 4 to the 5/2. I'll do that in the next step. 2 times 4, 2/3 times 4 to the 3/2. And when I put in 0, I get 0. We still good? All right, 16. 2/5 times. The square root of 4 is 2. 2 to the 5th is 32. The square root of 4 is 2. 2 cubed is 8. How about let's put the 16 and the 8 together. This will be 64 fifths and 16 thirds. We still good? Okay, then I changed it all to 15ths. Three into 15 is 5, so that's 80. 5 into 15 is 3, so that's 192. And then 24 times 15. 360. That's what I have. So 360 minus 192 minus 80. I got 176, but I guess I can't subtract. 88. What did I do? I must have added. Oh, thank you. I thought I made a mistake. So is 88 times 2 176? Yay. Okay. In part, well, first of all, you had to draw the graph for this, which was a challenge in itself. Plot points. If x is 0, y is 0. The domain of this function suggests that x cannot be smaller than -1 because I would get an imaginary number. So I put -1 in there to see what I get for y, and that is 0. Well, then I could pick any number to the right of -1. If I put in -1/2, this would be -1/2 plus 1 or +1/2. I don't know what that is, but I know it's a negative number. And then if I picked a number over here and put it in like 1, I have 1 times the square root of 2. Well, that's up here. So your graph looks like that. And it said that you had the region enclosed by this function and the line y equals 0. So here is your little region. And that was a job just getting to there. In part A, it says to find the area of that region. Area. Not revolving anything, just plain old area. So in that region, if I have to work with that problem and seeing how the equation is set up, I prefer a vertical rectangle. So what I'm doing is dividing that region into an infinite number of rectangles, finding the area of each one, and adding them all together. The adding them all together is the integration from where they start to where they stop. The area of a rectangle is length times width. Well, the length of it, top minus bottom, is 0 minus x square root of the quantity x plus 1. The width is dx. So that's how you set up part A. And to do it, you actually have to do that u substitution where you let u equal x plus 1, du is dx, but then you've got this thing to deal with, so you have to solve for x and then replace that in for this x, so that you would have negative x square root of, and then you can work it. I'm not going to work that out, but that's how we set it up. I got 4/15. If you want to work it later and check your arithmetic. I'd rather move on to part B. In part B, it says take that little region and revolve it around the x-axis. I still love that rectangle. If I revolve it around the x-axis, it gives me a circle, a circular disc. So for the disc method, I need to say pi times radius squared. The radius of that disc is the height of the rectangle, top minus bottom. And it's from -1 to 0. Squared, sorry. Pi radius squared. When you square that, you have that, which you can then integrate much more easily than in part A. And for that one, I got pi over 12. Am I going too fast? Did I lose somebody? I lost Zach. Zach's in La La Land. Are you? Yeah,
I
that's...
don't understand how it's top minus bottom and right minus left. I don't know which one to go to, ever. Yeah.
You don't know whether to use top minus bottom?
Like, I thought it was the farthest one and the closest one, not the top one and then the bottom one.
It depends if you're vertical or horizontal.
And it depends on if you're washer. It sounds like you're confusing washer. When I'm finding the outer radius, it's the furthermost point, the biggest radius. I can't even make a washer out of this one, can I?
But it's the farthest one and then the closest one that touches the region or whatever, and then it's the farthest one and then the one that touches the line. I know
You can make
that.
a washer
Yeah.
for that one.
So then for the disc, it's not the farthest, it's top minus bottom, even if it's whatever the axis is, whatever it's rotating on.
Yes. It wouldn't be a disc if it wasn't involving the line of rotation. If the
Okay.
region wasn't
But
involving.
that doesn't matter. It's just always the top minus the bottom of the region.
In part C of this problem, it says to revolve it about the y-axis, I think. I didn't write that down, but that looks like what I did. If I'm revolving this about the y-axis, that is a shell problem because my little favorite rectangle is parallel. So 2 pi times the average radius. What is the distance from the line I'm revolving about to that rectangle? Very good.
Right minus left.
Right minus left. What is the height?
Top minus bottom.
And what would that be? And there you go. You can clean it up a little bit. And this one again, you have to do that U substitution where then you solve for x to get something to replace this with. And the answer is 32 pi over 105. Nope. Okay. When you do the U substitution stuff, you have U equals x plus 1, so du is 2x. So if I have the 2 pi, and I'm replacing that with u, I can replace this with du. What am I going to do with that? So x is equal to u minus 1. So then I have u minus 1 squared. Then I have to FOIL this out, distribute square root of u to get the thing I'm going to integrate. Oh. So u to the 5 halves minus 2u to the 3 halves plus u to the 1 half. And my limits, I'll either change them or I will put u back in. But that's correct. So it is 32 pi over 5. 32 pi over 105. What did I say? Oh dear.